So now that we've discussed what a monitor object is in a general sense in terms of mutual exclusion and coordination, let's give you an example to motivate why we need these mechanisms in the first place. And the example we're going to use here is something that's called buggy queue for reasons that'll become clear in just a moment. And as you'll see, the way this example works is it's deliberately designed to have concurrent calls to the offer and poll methods corrupt the internal state of the fields in the buggy queue object. So it's intentionally designed to have race conditions. All right, so let's go ahead and take a look at the app here. You can actually download this app and play with it. It's in my GitHub repository, as you can see here under this link. And it's basically a concurrent producer-consumer app that attempts to pass messages between multiple threads using a buggy queue. Here's what it looks like. The buggy queue class is designed based on portions of the interface from the Java array bounded queue class. So we've talked about array bounded queue before when we were talking about the reentrant lock and condition object features that are part of Java. And so we kind of stole the interface here basically by implementing the blocking queue interface. And we're then going to show how to not do things correctly. Here's a UML diagram that kind of shows the relationship between the various elements in the design. So you can see here we have an interface, which I call simple blocking queue, which is kind of a subset of what's in Java blocking queue. And then we go ahead and implement that simple blocking queue interface to make a buggy queue. And here's a diagram that illustrates what's happening with buggy queue, and you'll hopefully see in a second why it's buggy. So what we're going to do here is we're going to start out by having a thread, which is the buggy queue test. And then we're going to have a consumer thread and a producer thread and a buggy queue. And the producer thread will, the object will be created and we'll start a thread running for the producer and the same thing for the consumer. And then the producer and consumer will sit there looping, offering elements into the queue, into the buggy queue, and then removing elements from the buggy queue. So we'll do offer and poll. And because, of course, there's no synchronization, the internal fields will be corrupted. And as a consequence, chaos and insanity will result when this app and its unit test are run. And it's kind of fun to run it because you get really bizarre results. So let's take a look and see how not to implement a blocking queue. So here's buggy queue. As you can see, buggy queue is going to implement simple blocking queue, which, as I mentioned before, is just kind of a subset of Java's blocking queue interface because we don't want to implement, dozens of methods for our simple example. Our implementation will use a linked list. One of the nice things about this is it would be relatively straightforward to replace the linked list with an array list. So we just use a linked list here just for kicks. And then we have two methods, offer and poll. And notice that both of these methods are not synchronized. There's no synchronized keyword at the method level. There's no synchronized keyword used as a part of a statement block inside of the offer or poll methods. Therefore, when you have multiple threads that are trying to offer and poll from the buggy queue object or from a buggy queue object, then you're going to have all kinds of problems because adding and removing elements from a queue that isn't synchronized from multiple threads is guaranteed to have problems because you're going to be modifying shared state, mutable shared state. So clearly this is a bad thing to do. You do not want to do this. And we'll show you shortly ways to fix this problem by using various mechanisms that are provided by Java's built-in monitor objects.